Software configuration management. Change is inevitable when computer software is built, and change increases the level of confusion when you and other members of a software team are working on a project. The art of coordinating software development to minimize the cost or confusion is called configuration management. Configuration management is the art of identifying, organizing, and controlling modifications to the software being built by a programming team. The goal is to maximize productivity by minimizing mistakes. Software configuration is also called change management. Software configuration management (SCM) can be viewed as a software quality assurance activity that is applied throughout the software process. In the sections that follow, we examine major SCM tasks and important concepts that help us to manage change. The progression of events that lead to a baseline is illustrated in this figure. Software engineering tasks produce one or more software configuration items. After software configuration items are reviewed and approved, they are placed in a project database, also called project library or software repository. When a member of a software engineering team wants to make a modification to a baseline software configuration item, SCI, it is copied from the project database into the engineer's private workspace. However, this extracted SCI can be modified only if SCM controls are followed. The arrows in the figure illustrate the modification path for a baseline SCI. Software configuration item. Software configuration item is the information that is created as part of the software engineering process. More realistically, an software configuration item SCI is all or part of a work product. For example, a document, an entire suite of test cases, or named program component. In reality, SCI are organized to form configuration objects that may be cataloged in the project database with a single name. A configuration object has name, attributes, and is connected to other objects by relationship. So this figure represents configuration object. The object has name and attributes as shown in the figure. The configuration objects are design specification, data model, component N, source code, and test specification. Each defined separately. However, each of the objects is related to others as shown by the arrows. A curved arrow indicates a compositional relation, that is, data model and component N are part of the object design specification. A double-headed straight arrow indicates an interrelationship. If a change were made to the source code object, the interrelationships enable you to determine what other objects, that is, software configuration items, might be affected. Software configuration management process, SCM process. Software configuration management is an important element of software quality assurance. Arnett Bennett says, any change, even a change for a better, is accompanied by drawbacks and discomforts. Software configuration management is an important element of software quality assurance. SCM process defines a series of tasks that have four primary objectives. 1. To identify all items that collectively define the software construction. 2. To manage changes to one or more of these items. 3. To facilitate the construction of different versions of an application. 4. To ensure that software quality is maintained as the configuration evolves over time. A process, SCM process, must be characterized in a manner that enables a software team to develop answers to a set of complex questions. How does an organization identify and manage the many existing versions of a program and its documentation in a manner that will enable change to be accommodated efficiently? How does an organization control changes before and after software is released to a customer? Who has the responsibility for approving and ranking changes? How can we ensure that changes have been made properly? What mechanism is used to appraise others of changes that are made? These questions lead us to the definition of 5 SCM tasks: identification, version control, change control, configuration auditing, and reporting. So in SCM process, we are learning SCM tasks such as identification, version control, change management, configuration auditing, and reporting. Let us learn in detail about these different SCM tasks or process. So first software configuration management task is identification of objects in the software configuration. To control and manage software configuration items, each must be separately named and then organized using an object-oriented approach. Actually, the interrelationships established for configuration objects allow you to assess the impact of change. Two types of objects can be identified: basic objects and aggregate objects. A basic object is a unit of text that has been created by a software engineer during analysis, design, code, or test. For example, a basic object might be a section of requirement specification, a source listing for a component, or a suite of test cases that are used to exercise the code. An aggregate object is a collection of basic objects and other aggregate objects. The identification scheme for software objects must recognize that objects evolve throughout the software process. Before an object is baselined, it may change many times, and even after a baseline has been established, changes may be quite frequent. It is possible to create an evolution graph for any object. The evolution graph describes the change history of an object as illustrated in this figure 9.3. In this evolution graph, configuration object 1.0 undergoes revision and becomes object 1.1. Minor corrections and changes results in versions 1.1.1 and 1.1.2, which is followed by a major update, that is object 2. The evolution of object 1.0 continues through 1.3 and 1.4, but at the same time, a major modification to the object results in a new evolutionary path, version 2.0. Both versions are currently supported. Version control. Version is an instance of a system which is functionally distinct in some way from other system instances. Version control combines procedures and tools to manage different versions of configuration objects that are created during the software process. One representation of the different versions of a system is the evolution graph presented in the previous slide. Each node on the graph is an aggregate object, that is, a complete version of the software. A version control tool is the first stage towards being able to manage multiple versions. Once it is in place, a detailed record of every version of the software must be kept. Each version of the software is a collection of SCIs, that is software configuration items, source code, documents, and data, and each version may be composed of different variants. To illustrate this concept, consider a version of a simple program that is composed of entities 1, 2, 3, 4, and 5. Variant is a set of SCI at the same version level with different functionality, and version is a change in the SCI spans a new version. Entity 4 is used only when the software is implemented using color displays. Entity 5 is implemented when monochrome displays are available. Therefore, two variants of the version can be defined. One, entities 1, 2, 3, and 4. Second, entities 1, 2, 3, and 5. A number of different automated approaches to version control have been proposed over the last few decades. The primary difference in approaches is the sophistication of the attributes that are used to construct specific versions and variants of a system and the mechanics of the process for construction. Next, software configuration management task is change control. For a large software engineering project, uncontrolled change rapidly leads to chaos. For such projects, change control combines human procedures and automated tools to provide a mechanism for the control of change. The change control process is illustrated schematically in this figure. A change control process is illustrated here. A change request is submitted and evaluated to assess technical merit, potential side effects, overall impact on other configuration objects and system functions, and the project cost of the change. The results of the evaluation are presented as a change report, which is used by a change control authority CCA, a person or group that makes a final decision on the status and priority of the change. An engineering change order ECO is generated for each approved change. The ECO describes the change to be made, the constraints that must be respected, and the criteria for review and audit. The objects to be changed can be placed in a directory that is controlled solely by the software engineer making the change. A version control system updates the original file once the change has been made. As an alternative, the object to be changed can be checked out of the project database. The change is made and appropriate SQA activities are applied. The object is then checked in to the database and appropriate version control mechanisms are used to create the next version of the software. These version control mechanisms, integrated within the change control process, implement two important elements of change management: access control and synchronization control. Access control governs which software engineers have the authority to access and modify a particular configuration object. Synchronization control helps to ensure that parallel changes performed by two different people do not override one another. Configuration audit. How can a software team ensure that the change has been properly implemented? The answer is twofold: technical reviews and software configuration audit. We are discussing about software configuration audit. A software configuration audit complements the formal technical review by assessing a configuration object for characteristics that are generally not considered during review. The audit asks and answers the following questions. Has the change specified in ECO been made? Have any additional modifications been incorporated? 2. Has a formal technical review been conducted to assess technical correctness? 3. Has the software process been followed and have software engineering standards been properly applied? 4. Has the change been highlighted in the SCI? Have the change date and change author been specified? Do the attributes of the configuration object reflect the change? Have SCM procedures for noting the change, recording it, and reporting it been followed? And finally, Have all related SCI been properly updated? These are the primary questions that we ask during a configuration audit. Such formal configuration audits also ensure that the correct SCI by version have been incorporated into a specific build and that all documentation is up to date and consistent with the version that has been built. Status reporting or configuration status reporting CSR. Configuration status reporting, sometimes called status accounting, is a software configuration management task that answers the following questions: what happened, who did it, when did it happen, what else will be affected. The flow of information for configuration status reporting CSR was illustrated in the figure that we discussed with the change control process. Each time a software configuration item is assigned new or updated identification, a configuration status report entry is made. Each time a change is approved by CCA, a configuration status reporting entry is made. Each time a configuration audit is conducted, the results are reported as part of the configuration status reporting task. Output from configuration status reporting CSR may be placed in an online database or website so that software developers or support staff can access change of information by keyword category. In addition, a CSR report is generated on a regular basis and is intended to keep management and practitioners apprised of important changes. Configuration status reporting plays a vital role in the success of a large software development project. When many people are involved, it is likely that the left hand not knowing what right hand is doing syndrome will occur.